one of the first things you have to do is to find a good candidate for your DLL hijacking. Okay. So as for the persistence, you have to have two things. One, something which is running at some point, either automatically or really triggered by something. So it has to be something triggered by, for example, by task scheduler or some run key or something like that. And the second thing is that that application has to be prone to DLL hijacking. Okay. You might remember from the previous video that we have investigated registry keys for run keys, right? So let me show you again the contents. And here you can see that there are three applications. Applications started at the user logon. And one of them is bginfo, which is the application from sysinternals, which sets up the desktop, you know, how it looks like, the background, etc. So let's see if we can write to the bginfo folder. So bginfo, and from the output you can see that the authenticated users can modify the folder. So let me check it out if it's actually if it's true. So we do a really simple test, and it looks like it succeeded. Now I need to make a note here. So you, like in reality, when you are on engagement, at this point you would copy out the whole, the whole application, so the whole folder into your test environment somewhere outside the target machine, and perform all the tests and development there. Okay, you wouldn't do that on your on the target machine on a live system, right? It's something obvious, but I wanted to, and I like highlight it here, that it's something important. Okay, so how we test if the bginfo is prone to DLL hijacking? So for that we will use one tool, also from sysinternals, and this tool is called Procmon, which allows you to monitor what is going on in the background in the system. Procmon. And specifically when you are targeting DLL hijacking, you would actually be setting two filters. So one filter is that the result, so the result column contains not found string, okay? And the second one is actually, we are targeting another process, which is bginfo. So with these two filters, you can see if there are any not found DLLs when the bginfo starts. Okay, so let's start it. Let us also start a process hacker. And let's start bginfo. So we go to C drive, bginfo, and we start it. Now we see something happening here in the background. The application has started, so let's suspend it because it quits really quickly. And let's see the output from process monitor. So we see a lot of DLLs which hasn't been found, right? like WinSock, version, SNMP API, etc. But it doesn't mean, so let's take a look at the process itself. So we go to modules, and we see that these DLLs are here. So WinSock is here, version is here, SNMP API is here. So why is that? The reason is, let's stop that. The reason is that these DLLs have been found in other folder. So here you can see it. The system loader didn't find that in the application folder. But if you turn off this filter, you will see that actually the WinSock DLL has been found in syswow64 folder. Okay, and this actually means that the BG-info is a 32-bit application. We can verify that here. It's a 32-bit application. Okay. So at this point, we have several candidate DLL candidates for hijacking, right? We have the application which is prone to DLL hijacking. We have the right capability to into the folder, application folder, and now we have a list of application DLLs which can be hijacked. Now, which DLL actually choose? So what I usually do is I run a dumpbin tool from Microsoft Visual Studio, which allows me to see all the imported DLLs by specific application. So in our case, it's a bginfo.exe. And now you see a lot of functions and a lot of DLLs which are needed by the BG-info application. So shell32, from that DLL, those functions are used. Only 32 are these, etc., etc. So what I'm looking for a DLL which BG-info uses only a small portion of functions. So winspool.drv has 3. only ACC has 3. Let me see if we can find a shorter list. No. SNMP API 3. Here we have 2, and only 1. But let me just for the exercise, let's focus on the one with the winspool.drv on those 3. Okay. So now what we need to develop a DLL which will act as a proxy between the application BG-info and the winspool.drv. So let's go to our course materials, and let's open up this file. And it looks like really simple DLL. So we have our DLL main function, which is called when the library is loaded into the process. And in this specific moment, we call the go function, which actually implements our malicious activity, so to speak. So in our case, I'm just creating a new process, launching our implant.exe. You can in reality, you would start some shellcode here, or some implant or something like that. But basically, for this exercise, I'm just launching implant. So as you can see, this application is really simple. and it lacks only one thing, which is proxying those three calls, function calls, to the original WinSpool. So how you can implement that? Of course, you could try to do some fancy stuff like loading the WinSpool DLL into the DRV into the process, and then get proc address and trying to match those. It's too complicated. The easier way is to use a linker from Visual Studio and to tell it that the specific function is actually implemented in different module. Okay, so in other words, if bginfo calls open printer a function from winspool.drv, okay, it will reach out to the address table and see that this function is actually implemented in winspl HLP. So it doesn't matter the name, what name you take here. What is the most important is it has to be a copy of the original DLL, okay? And this function is actually implemented in this call, and we also add the ordinal number from here. 8F is 143 in decimal, and ordinal is just a sort of index on the address in the address table. So we lack those two. So what we do here, we just copy this line 2 times. We take the close printer. So we paste it here, and for ordinal we have 1D. We can translate that in Python, print int 0x1D, and let's take the another number, 40. Okay, so 29 is here, 77 will be here, and the function name is here, so we take that here, here, save it. Let's go to parse 01 DL hijack, compile. Okay, no errors. So let's see if it works. Let's see the exports from our winspool.drv. Okay, so now we can see the export table from our DLL, that those three functions are actually forwarded to another module in those into those functions. And the last thing we need to do, let's clear it out. We need to copy our proxy DLL to the bginfo folder, and we also have to copy the original winspool.drv from syswo64 winspool to bginfo, but we have to call it like this one. Okay, DLL. So far so good. And so let's run. We can minimize that. We can unfreeze this bginfo and close that. And rerun bginfo again. And nothing happened. So let's investigate why it didn't work. So let's run it again. Let's suspend this application again and see, make sure that, so we have WinSpool has been loaded. The other DLL was not loaded, and we can make sure, yeah, this is actually the original one. Okay. And from that, do we see? Nope. So let me see if it actually has been loaded. WinSock version. And yep. So it looks like it worked. It's some sense, but so BGInfo found our hijacking DLL, but for some reason it didn't it didn't like it, and it took syswow 64-bit. So I did that mistake deliberately because I wanted to show you that sometimes you might encounter some problems. Okay, and the problem is that BGInfo is a 32-bit application, okay? But our DLL is actually 64-bit. And I know it from here that we are compiling, we are using 64-bit compiler, and you can actually check that with dumpbin tool, because it says it's 64-bit. So you cannot use 64-bit module in a 32-bit process. Okay, so we have to compile that DLL using 32-bit compiler. So let's get rid of that, close that, and now we go to Microsoft Visual Studio, and we launch x86 native tools command prompt. Okay, so we do the same thing. So we go to RTO pers01 DLL, compile it. Okay. Now we can try to find to verify. Now it's 86, so we can copy that back again, and let's see if it works now. And now it works. So let me suspend it. So you can see that BGInfo started our implant, which was actually launching our simple shellcode, Notepad shellcode. And if you go to modules, you will see that that our WinSpool DRV has been loaded. Okay. And the original module is also in memory of the process. Okay. Now let me show you one more thing, because it seems like everything is like good, right? But if you try to play with a tool and you go to printing, we get an error like before you can perform blah 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 something. No, there are some errors. Okay, and the reason is that sometimes implementing just only implementing only 3 functions, it's not enough. Because even if the information from the dump bin, as you could see, that bginfo only uses 3 functions, right? But in reality, it can also use getProcAddress functions and dynamically resolve the functions from the hijacking DLL. And in that case, our DLL is like, it's not ready for that. Okay. So what you could do, you could actually exports Windows syswow 64 and Windows spool, and actually do the same thing with all those functions. So you need to do progma comment for all those functions. Okay, and I let you do that as an assignment in this course. One thing you might be not familiar with and you get problems is that sometimes some functions are exported without any name, and they are callable only with using ordinal numbers. So in that case, you need to use that syntax. So for the function name, you put anything here. I use no name equals not name of the module dot hash and the number of ordinal. So as you can see here as an example, and we export it as ordinal number 100, and giving information to the linker that this specific function is only callable using ordinal without any name. Okay, so that's your so to speak homework. All right, guys, and the last thing we need to do, let's clean up this mess. So we go to just delete bginfo. Now if you run it, should be all good. Right. So that was DLL proxying.